Video 2.6 is all about balancing chemical reactions. So by the end of this video, you should be able to balance chemical reactions to show the conservation of mass. Make sure you also know what conservation of mass is, and you'll be able to identify some different types of chemical reactions. So conservation of mass basically is the knowledge that matter cannot be created or destroyed. So, all the matter that is in the universe now has been in the universe forever and will be in the universe forever going forward. It doesn't disappear, it just changes form, rearranges to recreate different things. The same is true in a chemical reaction. All the atoms and molecules that are there in the beginning with the reactants are there at the end with the products. None of them disappear or new ones appear or anything like that. The mass of a reaction has to stay constant from beginning to end. Because of that, when we look at chemical reactions, we have to make sure that they're balanced, which means that there are the same number of atoms on the reactant side or the left side of the equation that there are on the right side. So all those numbers need to match up. As you can see in this reaction of making water, they don't because there are two oxygens on this side, but only one oxygen on this side. Um, and we can't just draw a little 2. Let's see if I can do it. We can't just draw a little 2 right there because that gives us something completely different. H2O2 is hydrogen peroxide, and that's not what we want at all. Right? So we need to be real careful when we are balancing these reactions that we are doing it in the correct way. And the way that we can do that is we can only put numbers in front of each of the different components. Those are called coefficients. We cannot change the subscripts at all, but we can put different coefficients out here in front to balance our equation. I think the best way, easiest way to do this is just to kind of create a little chart. So here I have my little chart, and all I'm writing in the chart is the different atoms that are in my reaction. Hydrogen and oxygen, on both the left and the right hand side of the equation. Okay. The next thing I need to do is I go to my reaction and I count the number of each of these atoms that there are. So for this one, you can see here there's 2 hydrogens, 2 oxygens, then on the right hand side, 2 hydrogens and 1 oxygen. So I just jot those numbers down really quick. After that, it's just kind of like solving a puzzle. I need to make sure the numbers over here match the numbers over here. So in this reaction, what I might do is add a 2 right there. Remember, it has to be out in front, that coefficient. So I add a 2 there, and then I go through and I count again. So I'm done with those. Count again. Now I have 2 hydrogens here, 2 oxygens here. Because of this 2 right here, I have 4 hydrogens. 2 times 2 is 4. And 2 oxygens. So now I've fixed my oxygen problem, but I've created a hydrogen one. So there's a difference there between 4 and 2. So what I do next, well, I'll put a 2 right here. And get rid of these choices, or these numbers, and I go again. Now, 2 times 2 is 4. So there are 4 hydrogens on this side. Still 2 oxygens. We always assume the number is 1 there if it's missing. And 2 times 2 is 4 again. 4 hydrogens, 2 oxygens. So now everything matches up. I have 4 hydrogens on both sides. I have 2 oxygens on both sides. And so my equation is balanced. Let's see, let's try another example here. In this example, we have nitrogen and hydrogen. So basically, we have nitrogen and hydrogen combining to make ammonia. But on either side of the equation, I have nitrogen and hydrogen. Excuse my messy handwriting, but it's easier to draw this than to do that like I did before. So if I look at this, here I have 2 nitrogens, I have 2 hydrogens on the left-hand side. Coming over here to the right-hand side, I have 1 nitrogen and I have 3 hydrogens. So I kind of look at this. There are a couple different things you can do, ways you can solve this. So do what seems most obvious to you. But I'm going to deal first here with my nitrogens. There are 2 over here. There's only 1 over here, which means I'm going to put a 2 right there. Now, cross this out. Try it, go again. I have 2 nitrogens. Oh, that's a horrible 2. Let's redo that. No one can tell what that is. So I have 2 nitrogens. Sorry about that. 2 hydrogens, just like before. But now over here, I have 2 nitrogens. 2 times 3 is 6. So I have 6 hydrogens. So again, like before, this time I've worked out my nitrogens, but now my hydrogens are off, but at least they're off in a way I can figure out. Because if I just add a 3 right here, try to make it neat, then when I go back through and count, still 2 nitrogens, but this time 3 times 2 gives me 6 hydrogens. And over on the right hand side, 2 nitrogens, 6 hydrogens. So you can see everything matches up. So we've got this equation balanced. If it helps you to put a 1 here, you can, but you certainly don't need to. For this next example, I have lithium and oxygen combining to form lithium oxide. So if we just look at it just to start, there's 1 lithium, 2 oxygens. Then on the right hand side, there are 2 lithiums, 1 oxygen. So again, there's a couple different ways you can go. I always like to start, if I can, with putting the coefficient in front of the molecule instead of just the atoms individually. It makes things easier down the road. So if I look here, 2 lithiums, 1 lithium, 2 oxygens, 1 oxygen. So I might start by sticking a 2 right here. And then adding up again. Again, I still have 1 lithium here, 2 oxygens here. Now I have 4 lithiums here and 2 oxygens. So my oxygens equal out, my lithiums do not, but that's an easy fix. Right? I just need to add a 4 right here. And then when I look again, 4 lithium, 2 oxygen, 4 lithium, 2 oxygen. Everything matches up. My equation is balanced. Take a minute, pause the video, and try these for yourself. That one at the top there is a little bit complicated, but see what you can come up with. Just individually write out each of the atoms: lead, nitrogen, oxygen, potassium, chromium. Make sure you combine these 2 oxygens. And don't forget, this 2 out here means you have to distribute. So there's 2 nitrogens, 6 oxygens. So take a minute, pause, and see what you can come up with. Now let's check your answers and see how you did. For this top one, you should only need to put a 2 right here, which gives me 2 potassiums to match up there, and 2 nitrogens there, and 6 oxygens. Everything else should be nice and balanced. So not as difficult as it looks, even though there's lots of atoms there. For this one, you needed to put 2 4s here and here to give you your 4 carbons. Correct amount of oxygens. We'll also need to add a 6 there. And that balances that equation. Take a minute, pause the video to write down in your notes these types of reactions. We're going to talk about them and do a lab with them in class, but please make sure you stop the video and write these down very quickly. Well, you don't have to write them down quickly, but write them down. So now you should have been able to balance reactions, and